Here's my Cricut Joy that has a Bluetooth problem. There are a lot of other problems for which you will find some solutions online. It comes down to the pin is 1234, enabling the advanced Bluetooth discovery in Windows, in the settings or in the registry. And there are some people that claim that you can reset the Joy by moving back and forth the carriage 6 times. My problem wasn't fixed by any of this, so I had to investigate a bit further. So here's my problem. I want to connect to the Joy, but I'm asked to enter a 6-digit PIN on the Joy, which doesn't have any keys. Let's take a look at the tools I used to fix the Joy. A small Phillips screwdriver. Prying tools are always handy. Some jumper cables, a header and a breadboard for convenience, a probe with a fine tip, more jumper cables, a USB to TTL or UART adapter. It's important that this one runs on a logic level of 3.3 volt, as the chips built into the Joy run on this logic level, and the usual 5 volt might break the chips. Let's get started. First thing I did is remove the 4 plastic feet of the Joy. Next I removed the 4 screws on the bottom. And then I used the prying tool to open up the case of the Joy. Take a closer look at the board of the Joy. I will unscrew it. And unplug it so I can remove it. I had to be a bit careful about this last one, which is on the bottom side of the board. On the board are 2 important chips. One is the PIC32, which is kind of the main unit here and where the Joy's firmware is running on. And the other one up here is an RN4678, which is a widely used Bluetooth chip. This is the one I'm most interested in, as I am having a Bluetooth issue. Right next to the RN is a header with 8 pins, and right above it is testing point 511, which goes to ground. Another important pin is down here. It's the number 1 on this header. I will use it later to put the PIC into reset mode. I didn't want to solder the header to the board, so I just plugged it in, but for convenience I put my jumper into this header. So we got 5 pins here. Blue is clear to send, and yellow is request to send, so these are for hardware flow control. The white one is receive data, so this is where the RN actually receives information. Transmit is the green one, and black goes to ground. I don't have the board plugged in, so there's no power on here while I plug the header in. This here in the header, well, it's not as good as a soldered connection, but it worked for my purpose. Other side, my USB to TTL adapter. Again, same color coding. Ground is black, CTS is blue, green is transmitting, so here the USB adapter transmits, white is the receiving one, and again I didn't want to solder, so I just plugged in the yellow RTS in here. Now for my first insights, I just want to eavesdrop on the communication between the RN and the PIC, so I want to plug it in here white to white, RX to RX, so I can see what the RN is receiving. I did use Teraterm for my communication. First I had to do some settings. I went to setup, terminal, put the local echo on so I can see what I'm typing. And then I move over to the configuration for the serial port. The baud rate is important, which is 115,200. And for the moment, I will set the flow control to none, because the flow control is currently done by the PIC32, and I don't want to interfere with that. Now on this line, we see the commands that the PIC32 sends to the RN, which is $3 signs to enter the command mode, and then a lot of GET requests for different things, and 3 dashes in the end ends the command mode. Or in my case, I just saw the $3 signs and nothing else happened. Then I took a look on the other direction, what the RN answers to the PIC32. So I moved over and put my receiving end to the transmitting end of the RN. I now see what the RN answers to the PIC32, which is CMD, that acknowledges that we are entered command mode. Then a lot of answers to all the GET requests and the end command. I copy these as a backup for later. But first I got no answer at all because the RN was just not reacting to any commands. So before I could proceed, I had to get the RN back into command mode. Looking at the documentation, the RN has 33 pins. Pin 1 is up here, 2, 3, 4, and so on. Number 15 is down here in the lower left corner. Pin 22 is right here, and for me, the important ones were 26 and 27, as they are the ones that put the RN into command mode again. So 22, 23, 24, 25, 26. This is the one I want to pull to ground. For that, I just used a Cricut clamp on one side, put it to a spot that's also connected to ground, like this one right here. And then place the probe with a little helper right on pin 26. So in my case, it was 26 and 27 were the pins that put it into command mode. But from the documentation and that are the other pins I tested, it's also possible that pin 16, 24, 25, or 29 are the ones. I then connected my USB adapter in a way that I can send commands to the RN. So CTS goes now to my RTS, RTS to my CTS, the RN's RX to my TX, TX to RX, and still ground to ground. There's one more thing I did. I don't want the PIC32 to interfere with my commands, so I have to turn it off, and I can do that by connecting ground to first pin on the header down here, which puts the PIC32 into reset. Now back to the terminal, I have to make one change, which is the flow control, which I now send to RTS-CTS, because now my USB adapter is taking over a control from the PIC32. Now I can run the same commands that before the PIC32 did. So again, $3 to enter command mode, no enter needed here, and then one command after another, which are get requests, getting certain settings from the RN. These are all basic commands of the RN firmware, which are documented in the RN4678's documentation. I did copy all these values because I want to reset now the settings and then restore the settings one by one. SF,1 is the command to reset all the settings, so I enter. The RN acknowledges my command, and with R,1 I can reboot it. For me, this solved the issue of not being able to enter the command mode, so from now on me and also the PIC32 can just run commands on the RN. The message reboot is already one sign that the reset of the settings worked, because in the settings status codes were disabled before. I enter the command mode again with $3, and then I restore the settings one by one. SU03 sets the baud rate again. I do a quick reboot after this. Then I restore the rest of the settings as I had them before. Here it doesn't confirm my reboot because I disabled the status codes again with the line SO, comma, comma. Now I can finally fix my Bluetooth issue. There are 4 authentication modes. 2 of them, 1 and 3, they require some interaction with the Joy, which doesn't work because it doesn't have a display and it doesn't have keys. Number 2 and 4 are the ones that are working. Number 2 doesn't require any pin at all. And number 4 requires me to enter this default pin, which is 1, 2, 3, 4, on my computer. So I use mode number 2, just works, and set it by SA,2, and then I do a reboot with R,1. After I have done that, I can finally connect from my phone or computer to the Joy and use it again.